Space is vast, really, really vast. Think of the farthest star you can imagine. Now imagine traveling there. Even light, the fastest thing in the universe, takes years, centuries even, to journey across such distances. But what if there was a shortcut? What if we could fold space like a piece of paper and instantly travel from one point to another, millions of light years away? This is the tantalizing promise of wormholes. Imagine a cosmic tunnel, a shortcut through the fabric of space-time itself. These tunnels, if they exist, are called wormholes. They could connect distant corners of our universe, or even different universes altogether. Think of it like a cosmic subway system, whisking us across the cosmos in the blink of an eye. The idea of wormholes may sound like science fiction, and indeed, they've been featured in many a sci-fi story, but their roots lie firmly in real science, in the mind-bending equations of Albert Einstein's theory of general relativity. In the early 20th century, Albert Einstein revolutionized our understanding of gravity. He proposed that gravity wasn't a force acting across space, but rather the curvature of space-time itself. Massive objects, like stars and planets, warp the fabric of space-time around them, much like a bowling ball placed on a trampoline creates a dip. Einstein, along with physicist Nathan Rosen, took this idea even further. They realized that, mathematically speaking, extremely strong gravitational fields could create a bridge, a tunnel connecting two different points in space-time. This hypothetical tunnel, later dubbed an Einstein-Rosen bridge, is what we now call a wormhole. Imagine two ants crawling on a large sheet. Normally they'd have to travel across the entire sheet to reach each other, but if the sheet were folded in half, creating a shortcut tunnel, they could reach each other much faster. That's the basic idea behind a wormhole, a shortcut through the fabric of space-time. However, there's a catch. These theoretical wormholes, as predicted by Einstein's equations, would be incredibly unstable. They would collapse faster than the blink of an eye, making it impossible for anything to travel through them. So, how might these cosmic tunnels actually form? The answer likely lies in the most extreme gravitational environments in the universe, black holes. These cosmic monsters warp space-time so severely that they could, theoretically, create a rip in the fabric of space-time itself, potentially forming a wormhole. But even if black holes do give birth to wormholes, keeping them open long enough for anything to travel through is another challenge altogether. This is where the concept of exotic matter comes in. Exotic matter is hypothetical matter with negative energy density, a concept that boggles the mind but is allowed by some theoretical physics models. Imagine exotic matter as the scaffolding that holds the wormhole open, preventing it from collapsing in on itself. Think of it like putting poles inside a tent to keep it from collapsing. Whether exotic matter exists, and if so, how it behaves, is still a mystery, a question for future physicists to unravel. The idea of wormholes, these cosmic shortcuts through space-time, has captured the imaginations of scientists and science fiction writers alike. Could we one day journey through a wormhole to reach distant galaxies, exploring the cosmos like never before? Perhaps the most intriguing possibility is that wormholes might allow for time travel. If we could somehow manipulate the entrances and exits of a wormhole, we might be able to create a time machine, traveling to the past or the future. Of course, this raises all sorts of paradoxes and questions about the nature of causality. From the cosmic horrors of Event Horizon to the interstellar voyages of Interstellar, wormholes have become a staple of science fiction, allowing us to explore the mind-bending possibilities of the universe. While the reality of wormholes remains firmly in the realm of speculation, the very idea continues to inspire and fuel our curiosity about the universe and our place within it.